Hello and welcome back to another video. In this video we are going to discuss the last 3 questions from the March 2019 970962, that is probability and statistics 1, that is 5th, 6th and 7th question. So let's start with the question number 5. So here's the question number 5. The weights in kg of 11 members of dolphin swimming team and the 11 members of shark swimming team are shown below. This is for the data for the dolphins and this is data for the sharks. And first question is draw a back-to-back stem and leaf diagram to represent this information with the dolphins on the left hand side. So dolphin will be coming here towards the left hand sides and shark on the right hand side. So it is like going to be sharks here, and key will get it from here because it's dolphin, it is shark. So if I wrote 6 and here it is 2 and here it is 8, it means 62 dolphin and 68 sharks. Not sharks actually, this swimming team. So it's like 62 members from the dolphin swimming team and 68 members from the shark swimming team. Just I have written like that. Now we need to draw a line, two vertical line, where we'll be giving the entry for this key. So since the least value is in the sharks in the 50s, so we will start from 5, and maximum value we can see in both, it is 80s, so we'll go till 8. So 5, 6, 7 and 8. So let's fill for dolphins. So first one, there is nothing from in 50s, so we'll not write anything. And in 60s, this is 62, 69, 63, 65, 65. So we'll write in the ascending order starting from here. So the least value is 62, so it is going to be 2 here, and then 3, 63, and then 65 twice, so it is going to be 65 and 65 here, and then 69, so it is going to be 9 here. That should be equally spaced. And now in 70s, this is 75, 73 and 72, so in the ascending order it is going to be 72, 2, 73, so it is 3, and 75, so it is 5. And in 80s it is 82, 80 and 82, so 82 and 80s, so 80 will come here 0, and then 82 and then again 82, so it is going to be for the dolphins. All the data we have entered, we can see it is 3, 3, 6, 3, 9 to 11. All the 11 data are there for the dolphins swimming team. Now for the sharks it is going to be 59 in 50s, so it is 9 here, and in 60s 68, 64, 66. So in the ascending order again we'll start from this place only. So first one is going to be 64 and then 66 and then 68, so again equally spaced. And in 70s it is 70, 71, 77 and 72, 74. So first one 70, then 71, so 1, 72, then 74 and then 77 again. Now for in 80s it is 84 and 80, so 84 and 80 it is 80 and it is 84, so it is 4. Again we can cross check whether we have entered all the data or not. 2 to 4 to 6, 7, 8, 9, 10, 11, all the data we have entered. So that's the back-to-back stem and leaf diagram. I hope it is clear. Let's do the next question. Here's the second part of this question. Find the median and interquartile range for the dolphins. So only for the dolphins we need to calculate median. Median is going to be, we express it as Q2 as well, so we need to calculate Q2. And interquartile range, for interquartile range, that is IQR, we need to get the upper quartile, that is Q3, and then lower quartile Q1, and we'll subtract it to get the interquartile range for that. So first of all we need to see, for this we need to see the stem and leaf diagram. So let me bring it here. So in the dolphins or in the shark there are 11 datas, So for median we are going to calculate 11 by 2, and that is 5.5, which is less than 6 and greater than 5. So Q2, from here we know that if it is integral value, then it is a sum of the two consecutive values and divide by 2. Otherwise, if it is not integer, then we are going to take the next integral value, that is 5.5. so in this case we will take the sixth value. So Q2, that is median, is going to be sixth value, and it is 1, 2, 3, 4, 5 and 6. So it is 72. So median is 72. And for Q1 we are going to calculate 11 over 4, that is going to be 2.75 again. So we will take the next value. So Q1 is going to be third value, and third value is 65. 1, 2, 3, 65. And Q3 is going to be 3 by 4 times 11, that is going to be 2.75 into 3 only. So it is 8.25. So again it is not an integral value, so we will take this Q3 as the next value, that is going to be ninth value. Ninth value is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and that is 80. So now from here we can calculate interquartile range, that is Q3 minus Q1, 80 minus 65, and it is going to be 15. So interquartile range is 15. So I hope it is clear. Let's do the next question. Question number 6. The results of a survey by a large supermarket show that 35% of its customers shop online. First question is, 6 customers are chosen at random. Find the probability that more than 3 of them shop online. So we can see it is we are going to do the survey or find the probability only out of 6. So it seems, and we can understand that it is going to be a binomial. Why? Because we are going to, this condition is either they will shop online or not. So it is going to be binary. That's why it is binomial. Random variable x, discrete random variable x, and that is going to be number of people, or number of customers who choose to shop online. So if it is number of customers who choose to shop online, then the corresponding success probability P would be 35%, because 35% of the customers shop online. So it is going to be 0.35. P is 35%, 35 over 100, that is 0.35, and x is binomial with the parameters 6 and 0.35. Now if we have the binomial and we need to find the probability that more than 3 of them, so it is going to be probability of x more than 3. So we need to find this probability, and we know that it is a discrete. So if it is greater than 3, so it would be probability of x is equal to 4, or that is plus probability of x is equal to 5, or so plus again probability of x is equal to 6, because there are total 6 data. So now we are going to calculate this, and we know we have the formula for it, because if it is a binomial, in the binomial the probability of x is equal to r is NCR, success probability to the power r, and failure probability to the power n minus r. So from here, if p is this, then the probability that customer will not shop online is going to be 1 minus p, that is 0.65. So if we need to calculate probability of x is equal to 4, it is going to be total 6c4 and 0.35 to the power 4, and the remaining 2 will not shop, so it is 0.65 to the power 2, or 6c5 0.35 to the power 5 and 0.65 to the power 1, and the last 6c6 0.35 to the power 6 and no one shop offline, so it is 0. And this is going to be, we know that we can calculate it directly also, but I'll do it one by one. And we know that 64 is 15, and this is going to be 0.35 to the power 4 and 0.65 to the power 2 here, and 65 is going to be 6, so it is going to be 0.35 to the power 5 and 0.65 plus 66 is going to be 1, so it is going to be 0.35 to the power 6 only, because this is also 1. Now we can use the calculator and directly give the answer, and the answer is 0.1174, so it is 0.117. This is the probability that more than 3 out of 6 customers will shop online. I hope it is clear. Let's do the next part of this question. Here's the second part. For a random sample of n customers, the probability that at least one of them shops online is greater than 0.95. Find the probability find the least possible value of n. So this data we can write, because we know that it is binomial, so it is going to be binomial of parameter n, and success probability is 0.35 still, but n we need to find. So it is binomial, and the at least one of them is going to be, we will represent in the probability form. At least one is going to be probability of x is greater than or equal to 1, and this probability is greater than again 0.95. So what we are going to do, we are going to calculate this, and we know it is going to start from 1 and going till n, so we don't know the value of n, so we cannot calculate. So we will convert this in form 1 minus probability of x less than 1, and we know that it's discrete, so if it is less than 1, so only possibility left is x is equal to 0, and as it is we'll write the rest of the things. So now the formula, we have the formula for it. It is going to be 1 minus nc0 success probability is power 0, that is 0.35 to the power 0 and 0.65 to the power all, that is n, greater than 0.95. Now we know that nc0 is 1, 0.35 to the power 0 is 1, so it is only, we are only left with 1 minus 0.65 to the power n, which is greater than 0.95. Now I'll translate this thing over here and this thing over here to get the value as 0.1 minus 0.95 greater than 0.65 to the power n, and it is 0.05. Now we need to take the log of both the side, so I'll take ln both the side and we'll get ln 0.05. And how else we can find? We can directly guess also. If we have doubt in the ln. So it is going to be 0. I'll do it by both the methods. It is 0.05, then ln, and then we know it is going to be n, and then ln to the ln of 0.65 natural log, and we know since ln value, this log, we are going to find the log of a value which is less than 1, so it would be less than 0. So if I am going to divide this whole inequality by log of 0.65, then it would be interchanged. This inequality will be interchanged, so it is ln of 0.05 divide by ln of 0.65, and this inequality will become n greater than, and this is n, and this value we will calculate of course from the calculator. It is coming 6.954 and so on. So this is going to be greater than n, or so n value, the least possible value is going to, which is more than 6.95 is, so least value of n is 7. Otherwise, now if we want to do by guessing, then we need to calculate this by putting the value 0.65 in the calculator and keep on doing for different values of n. So we can see it is going to be 0.65 and that should be less than 0.05. So we can of course not put the n value as 1, so we can start from n is equal to 2. So we can have for n is equal to 2 also, what is this value? So 0.6 point, this is going to be, for n is equal to 2, this value 0.65 to the power n value is coming 0.4225, which is of course very bigger than that. So we'll check for other value little bit bigger. So let's check for n value as 8, or let's say 6. So if it is 6, for n is equal to 6, it is a trial and error method, so we can get it is as 0.075, so which is little bit closer to it. And now again we'll check for n is equal to 7, so it is coming 0.049, which is of course less than 0.05. So now we can get it from here also, the least possible values for n is equal to 7. And if we of course calculate for n is equal to more than 7, so it would be less than this value as well. So that will always be true, but that least value, for the least value it is n is equal to 7. So in any way we can do this question. So I hope it is clear. Let's do the next question. This is the third part of this question. For a random sample of 100 customers, use a suitable approximating distribution to find the probability that more than 39 shops online. Now if we are going to take the random sample as 100, which is of course very big number, which is more than 9, n is equal to 30 we can say, or 50. So in this case the binomial b of np, this distribution we can approximate by normal distribution, and for the normal distribution we know we require the mean and variance. So from the and we know that for this p is equal to 0.35. So from here we know for the binomial the mean is n into p, that is going to be 100 into 0.35, so 35, and variance is going to be npq, so it is 100 into 0.35 into 0.65, and so this is going to be 22.75. So now if we have both the values, then we can convert it into the approximate with the into the approximate normal distribution. So it become x is approximated with the normal distribution with the parameters 35 and 22.75. So now from the normal distribution we know that if we need to get the probability of more than 39, so it is going to be probability of x more than 39. In the it is continuous data, so we will not take this as equality, so it is always going to be greater than 39 only. Another thing is, when we are approximating the discrete, we are going to approximate discrete random variable to continuous random variable, so we need to do the continuity correction as well. So for continuity correction there is a fixed thing, like if we draw the 39 here, 39, and we know it is 39, then 38 here, and then 40 here, so we make a gap of 5, equal gap. So it's like if we are going x greater than 39, so if we are going in this direction, and if you are not including the 39, then we should not include this complete bar as well. So it is going to start from this place, 39.5. So we can say it is going to be probability of x is greater than 39.5, and which is going to be in the normalization form is probability of z greater than 39.5 minus mean, that is 35, over sigma, that is root of 22.75 standard deviation. And how we write it, we know that it is going to be z is greater than x minus mu over sigma, and x is this value. So we have to be very careful when we are approximating a discrete random variable into the continuous random variable. Then we need to do the continuity correction, which is like if we are not including the number, like in this case we are not including the number, then we will not include the bar. If you are including the number, then we will include the bar. In that case it would be starting from 38.5. so now we will calculate this from the calculator, and it is going to be z is greater than 0.9434, so 5, so it is going to be 345, it is 5. Now we will draw the normal diagram, this distribution graph, and we can see it is going to be 0.945, so it would be positive, it is positive, so it would be coming somewhere here, and we need to calculate the probability greater than this. So we need to get this area, and we know this area, the less than area is represented by phi. So if we take this as this value, as we can calculate, this value is going to be phi of this value, and this is 0.9435 from the question. So we have 0.9435, this area is 0.9435, phi of 0.9435, and we require this, so we are going to calculate 1 minus phi of 0.9435. now this value we will get it from the distribution table, and this whole answer become this 1 minus 0.8272, so it is going to be 0.1728, which is still 3 significant figure, it is 0.173, because we need to write our answer till 3 significant figures, so it is 0.173. so I hope it is clear. Let's do the next question. So here's the question number 7. Find the number of different arrangements that can be made of all 9 different arrangements of all 9 letters in the word cameraman in each of the following cases. So first one is there are no restrictions at all. So if there are no restrictions, then we can find if there are some letters repeating. So we can see there are 2 M's and 3 A's, 2 M 1 2 and 3 A 1 2 3. So the total number of arrangement would be 9 factorial upon 2 factorial for 2 M's and 3 factorial for 3 A's. We are dividing this because these are same, so they will be giving the same word again and again. That's why we are dividing by 2 factorial and 3 factorial. And the second one is the first place, 5th place and 9th place is occupied by this A. So we can write it as A, first place, 1 2 3 4 5, and then 6 7 8 9. So these 3 letters, since they are same only, so we can arrange them in at 3 places by 3 factorial over 3 factorial, because they all are same, into now we are going to fix the 6 places. We are going to arrange the 6 places, and for these 6 places we have 3 A's as well, 2 M as well. So it is going to be 6 factorial upon 2 factorial, because A and then for the others, so it is going to be 6 factorial over 2 factorial, and 6 factorial is to 720 over 2 factorial, that is 2, so this is going to be 360 only. I hope it is clear. Let's do the third part of this question. So the third part, there is exactly one letter between the M's. So there are 9 places altogether, because in the cameraman there are 9 letters, 1 2 3 4 5 6 7 8 9. So if we are starting from any side, let's say I'll start from here. So if it is M, then there would be a gap, because exactly one letter, and then there would be another M. So for this 7 places, remaining 7 places, we can arrange any letter in 7 factorial over 3 factorial ways. And so for this M, we have 7 places to go. Like if we are taking this place, then it is okay. Otherwise we can choose these 2 places, another 2, and then if we can choose this and this 3, and then 4 would be this one, 5 would be this one, 6 would be this one, and 7 would be this one. So we can fix this position, arrange this to M in 7 ways. So it is going to be into 7. So 7 factorial by 3 factorial for the rest of the alpha letters, and 7 for the arrangement of these two M on these in this spaces. So I guess it is okay, and so the answer is going to be 7 factorial upon 3 factorial. So it is going to be 7 into 6 into 5 into 4, and 3 factorial cancel, so it is going to be into 7, and the whole we calculate it is 5880 ways arrangement where there is exactly one letter between the M's. So let's do the next question. For the fourth part, 3 letters are selected. Earlier it was arrangement, now this is selection for 9 letters of the word cameraman. Find the number of different selections if the 3 letters include exactly one M and exactly one A. So if we want to select them, it's like if we have selected one M and one A, then it means it is gone from the total letters. So it means there is no any other M and A present here. So only need to what we need to select, we need to only choose one letter out of these remaining, that is 4. So the total number of selection would be 4, because M and N should come only once, and 3 letters we are going to choose. So for one place, for one selection, that is going to be 4C1, and 4C1 is 4 factorial upon 1 factorial and 3 factorial, and that is going to be 4 only. Now fifth part, find the number of different selections if the 3 letters include at least one M. At least one M. So we are going to now differentiate these two, because A, out of these 3 A's, if it does not matter which A we are selecting, it is only one A. So I will take it as 1 M, at least one. So 1 M or 2 M in 2 ways, 1 M and 2 non-A values, 2 M and non-A value, non-A letter, and otherwise 1 M and both the A came here, or 2 M and 1 A came here. So for if we are not choosing A in this place, so it is going to be out of 1 2 3 4C 2 ways. We can select this for these 2 places in 4C 2 ways, and this can be selected by 4C 1 way. And M, if it is 1 M and 2 A's, so 2 A we can select in one way only, so it is going to be 1. And for this, if 1 A want to select, it is going to be again in the one way. And one last option is left if we are going to choose 1 M and 1 A has been selected, because we don't know anything about the other one. Suppose 1 A is being selected, in that case the rest, that one place can be filled in, like we have removed M, we have selected M, we have selected A, so this place can be filled by 4C 1 ways. So these are the all possible selections, I think, and because we have selected when there is no A at all, in both the cases at least one M and 2 M, or when we fix that this is going to be these two spaces is going to be filled by A, this one space is again going to be filled by A, and if one place is occupied by A and the another one is occupied by non-A value. So these are the all possible selections. So it is going to be total number of selection is going to be 4C2 plus 4C1 plus 1 plus 1 plus 4C1 ways. So 4C2 4c2 is 4 factorial over 2 factorial and 2 factorial, so it is going to be 6, 3 2 just 6, 6 plus 4c1 is 4 plus 1 plus 1 plus 4c1 is again 4, so it is 4 6 10 12 4 16. So there are total number of total different selections are 16. So I hope it is clear. Let's meet again in the next video. Till then, thank you so much.